It's fantastic to be here and to talk to such a large group, and I've been assured that most of you will not know anything about me, so that's great. I can tell the same old jokes and can go to sleep. I won't do that, but as Paul has alluded, the research that I do is at the far more clinical end, and although I am a physiotherapist, I am now affiliated with the physiotherapy school. I wasn't for a long time. I worked as a physio for 7 or 8 years after university and decided that I did not want to be a physiotherapist anymore, and I treated a fellow very badly, and I can remember that he had low back and leg pain, but that's all that I remember about him. And I did not know what was causing his low back and leg pain. So I said to him in true clinician effect, I said, I know exactly what's wrong with you. And if we do this and that, and I had this very intricate solution to his complex problem that involved at least putting something in his shoe and using tape to do something with his bottom muscle. I was a gifted clinician. And he never came back. So clearly I had fixed him. So I do the sort of cognitive neuroscience, clinical neuroscience, applied real-life humans. The most fundamental thing that we do is systems, behavioural and neuroscience studies. So we do things to humans and we see how they report it and how they behave. I have disclosures. Bias is a really big issue in what we do, and I think it comes into research across the board. So I think it's important that I actually put this up for long enough for you to see what might be the influences over what I do and what I tell you. So I have vested interests here that I can't control because I am a human. And that theme comes through what we do in research. We're very interested in how and why the brain produces experiences and makes decisions about biological advantage. And bias comes into that. What normally happens at conferences is people do this. They say, and they're my disclosures. So I thought I might give you a background into why I went down the pain route eventually. I think it's always helpful if you don't know someone to sort of get an idea of what's inside them, what makes them tick. This is just one of the animal models we've been working on. I've summarised here a large group of studies done by several groups, but most obviously synthesised by these guys a long time ago, and I learnt about this when I was an undergraduate student. I thought it was just fantastic. But if you give supposedly normal healthy volunteers an aspirin, they get pain relief from that. And if you give them a placebo, they get pain relief. They get more relief from the aspirin than they do from the placebo. Nothing very surprising. If you do absolutely nothing, they get pain relief. Which is good. If you're a clinical health professional, that's fantastic, because you can just say, just have a seat there, and 15 minutes later, how are you feeling now? Well, I'm feeling quite good, actually. That's $65. Thanks very much. It's fantastic. If you give someone an aspirin and it's branded aspirin, these are the data from way back, but we could say if you give someone paracetamol that's Panadol, let's say, it's going to have a bigger analgesic effect than just the paracetamol, so long as it's branded and it's in the right colour box and all that sort of stuff. If you give them a branded placebo, so now we're starting to deceive them. We say, here's a Panadol. And it's not. It's just it's a nothing tablet. They get more pain relief than if you gave them the nothing tablet that they don't think is Panadol. Now, some of you have probably heard the statistic somewhere, 30% of people respond to placebos. Well, I'd like you to cast that out of your mind. Everyone should respond to a placebo if there is credible evidence that it's something else. And this is the thing that excites me academically, that everything that's mediating this should be capturable for us in a clinical sense. These guys can split up these effects, and over a range of studies they can look at, okay, well, what's the effect of doing nothing? What's the effect of taking a pill, the actual action of taking a pill? What's the effect of the branding, and what's the effect of the drug? So here, in orange, Remembering this is just me synthesising a whole bunch of data. But there's the drug effect. That's a significant effect, one that we should be trying to capture, and one that people at this university are leading the world in targeting that effect. There's a few placebo studies around. So if you look at this systematic review data, many of these studies are systematic reviews with sometimes hundreds of studies in them. It's a massive literature. And it tells some interesting things to us. That subcutaneous injections of a placebo generate a stronger effect than taking the pill orally. Cool. There's a book that's just published by a very good orthopaedic researcher in Sydney. I think it was released a week ago, called Surgery, the Best Placebo We've Got, or the Best Placebo Ever. I can't wait to read it. It's a very controversial title, particularly for his community. But there's pretty good evidence that surgeries can be very effective so long as you think you're having surgery. There was a great study in the US with a fellow whose surname was Moseley, actually, same surname as me, and it was a paper in the New England Journal of Medicine. So I put that on my CV and no one's realised it's not me yet. Right, so I get grants and stuff. I'll say, well, I've got a New England Journal paper. Just hope they don't look at the initial. So what Moseley et al. Showed was the results of a study of arthroscopy for knee pain. And they blinded the patients and they blinded the assessors to whether they actually did the arthroscope, go in, nip off the bit of cartilage, clean it out, or make the holes, flush it with salty water, and then come out, so do nothing. And the two groups had very similar outcomes, and interviews with the patients who got the placebo showed quite clearly that they just would not believe they got the placebo. They said, well, there's something wrong with the study because I know that I got the surgery. And how do you know that? Well, my knee was better immediately. And I think, isn't that quite remarkable? And then you explore that more and they talk, well, I knew when I was in the study. I've seen that doctor on the sideline with the Chicago Bulls. He's orthopaedic surgeon to the stars. And as I think about those things, I think more and more, what are the cues that are coming into that brain, that multi-dimensional, highly processing organ that can convert that cue into a changed output, into an altered output, altered pain. So let's put it in there. Having a pill might give us this, having an injection gives us this size effect, taking the pill gives us this. The drug effect is the same, natural history is the same, but now we can differentiate the two clinical interactions. The size of the placebo effect might depend on the clinician who's treating the patient. Certainly does, right? You go to one, let's say one physiotherapist, and you walk in and you see them and you think, I'm going to be better. Look at the way they walk. And I'll let you in on a secret. Physiotherapists know better than anyone else how to do the pelvic tilt. I will demonstrate this for you now. That is the pelvic tilt. And when you're a patient and you see the physiotherapist walking towards you going like this, you know straight away, I am half better. I'm getting cues. This person knows exactly how the body works. Look at that control. Capsules are more effective than tablets. Transparent capsules with little bubbles in them are more effective than white capsules, and if the bubbles are light blue, they're more effective for pain relief than if they're beige or red. This is real data for pain relief. Supposedly normal, healthy volunteers. Now, I always describe our subjects as that because they're volunteering for pain experiments. They're clearly not normal people. All right, there's something else going on. But supposedly normal people get a greater analgesic response to a pill, a capsule that you can see through that, in fact, even better, has two different coloured balls inside it. And they are all cues, in my view, they are all cues that are telling the brain what's coming next, what's the prediction, because the brain is a predictor, if you like. What is the prediction? And I'll try and create that in advance of the sensory signals. I mean, very, very sophisticated, cool stuff that we're not aware of, but we can exploit clinically. One of my favourite studies, I remember being fascinated by this, Richard Gracely did this study. It was a double-blind, placebo-controlled trial of fentanyl, powerful analgesic, during wisdom tooth removal. Now, I always love the idea of a double-blind dentist trial. Imagine you're sitting in the chair and the person comes. The dentists were blind to what they were injecting. The patients were blind to what they were having injected, and in a subset of these dentists, they played a trick on the dentists. And they randomly allocated some of the dentists to be told, we've got no fentanyl. Sorry, there's been a stuff up. You'll only be injecting the placebo, but do not let the patients know. We'll sort it out later. Have you got the design? So 50% are told, oh sorry, this is the patient data, don't worry about that. Some of the dentists are told there's a 50% chance this is a placebo, that's the truth, and some are deceived by being told there's a 100% chance it's a placebo, but don't let the patient know, and these are the results, these are the response to placebo injection in that group. So the patients who had a dentist who thought they can't be injecting fentanyl, their pain got worse, and the patients who had a dentist who thought there was a 50% chance, their pain got better. There's an analgesic response to that. And these guys went one step further and showed videos, movies of the interactions, and said to the person watching the video, tell me which group you think this dentist was in. No better than chance at picking the group. So an outsider viewing this interaction cannot determine what the dentist thinks, but the patient picks it up. How cool is that? If there's anyone working clinically, how cool is that? The way you walk and talk and throw your keys on the table and have your leather briefcase there could potentially all be sending cues about what's coming next, about safety. And I find that very, very, very fascinating. So, here are some things that I think are important, and I've tried to construct some stories here that I hope will be a little bit provocative, and I've been given license to do that from Paul. Thank you very much. These are things that we tend to group together in our society, and I'm coming from the clinical space, and I think in the basic science space, these things are grouped together as well. Nociception, pain and behaviour, particularly nociception and pain. What I mean by nociceptor, and this is not my idea, it's the idea to which I subscribe, is that nociception is activity in particular neurons in the tissues of your body that are high threshold neurons, they're hard to activate, and they're projections. So we have primary nociceptors in the tissues and spinal nociceptors that take a danger message to the brain, saying there's danger in my part of the body, if you like. Pain, on the other hand, is an unpleasant feeling you have in a part of your body. So it's easy to see how those two things can be conflated, but in my view, it's a conflation. The behaviour I see as the response to pain, really the effect of pain, is the behavioural response. You seek help, you worry, you think about it, you do all sorts of stuff. You might brace yourself, consciously brace yourself. You might decide to freeze. So I'm not saying that all freezing is a response to pain. Clearly it's not. But you might decide, I'm not moving. They're behavioural responses to pain. And we're developing a bigger respect over time when we look at the massive burden of chronic pain, which costs Western societies more than cancer and diabetes combined. It's a massive, massive financial burden. What we're realising, because none of our treatments have been working very well with chronic pain, is that we need to think more broadly. We're not just thinking about pain as a protective output, but about the other things. And from a physiotherapy background, the motor side is something that we've spent a lot of time, I guess, cutting our teeth on. But pain and motor outputs are just two of the protective systems available to us as humans. And I would say that nociception is just one of the danger inputs that modulate pain. Now, it's a really powerful modulation. And from a neural representation theory perspective or artificial networks, you would say that nociception is a highly influential input. But I think there's compelling evidence to say that nociception is not sufficient to trigger pain. And we can prove that, and we're always looking for subjects for these sort of experiments where if we chop off your head and we deliver a noxious stimulus, there is no pain. So nociception is not enough. And neither is nociception critical for that, although those situations are harder to conjure. Here's the experiments that are still rolled out to support the idea that nociception and pain are the same thing. And I'll demonstrate them to you by telling you what they sound like. This is the pain generated or experienced by someone on average when a hot thermode is put on the back of their hand. Ow, 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 ow. Doesn't matter what the intensity is, it just stays constant for the 30 seconds of the thermode. This might be what happens in C fibres. If you're listening to the C fibre, it might sound like this. And then they say, okay, and then we've got another fibre called the A delta, and they do this. Dit, 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 keeps going. So the argument that's given to say nociception and pain are isomorphic or are appropriately grouped as the same thing is that plus equals. It's not a very sophisticated argument, but it's quite seductive intellectually. It's quite a seductive argument. If that's true, then we should not be able to find experiences in life where we change C fibre and A delta fibres without changing pain, or we change pain without having changed A delta and C fibre activation. So, in another way, we should not have situations where we change pain without changing nociception, or the other way around. Here's an experiment that we did that we think gives pretty compelling evidence against that model, and it's just one study of many done by our group and many groups. We got supposedly normal healthy volunteers to let us put a very cold thermode on the back of their hand. Minus 21 degrees onto the back of their hand. What we also did was showed them one of two lights. Now, we didn't say anything about the light, but we just turned the light on at the same time as the stimulus. One light was red. We think that implies cues about danger and heat. I forgot to say, I'm very happy with the mobile phones being left on. I don't mind about that at all, but if it's near me, I'm allowed to answer it. And I did this once. It was on the table in front of me, and I picked it up, and I said, "Good evening." And the person on the other end said, "Is she with you?" And I said, "She certainly is." We're a little bit busy here. Can she call you back? So we've got one cue that's red, and we've got another cue that's light blue. And light blue means different things. There's meaning to those inputs. And there's a lot of different data here. This is the key data, that when people see a red light, exactly the same stimulus every single time, it tends to hurt more than if they saw the blue light. But the nociceptive input is identical to this cue. Now, if you look closely, there are some people like this person here. There's no effect. No effect. They're idiots. Because they're not picking up on the cues that for the rest of us are powerful drivers of behaviour. And like it or not, these things are driving your behaviour and your experiences all the time. It's not just about pain. This is, I think these are fascinating studies. If you get a group of Westerners and you give them a light blue pill, they get a bit sedated. They feel a little bit lethargic on average. Their reaction times get slower. That's quite amazing. Their heart rate reduces, their respiratory rate reduces, but if you give them a bright red pill, it has the opposite effect. And this is interpreted as the effect of the colour of the pill. This has been replicated, well established. There's one exception to this rule, Italian men. And in Italian men, the light blue pill does the same thing as the bright red pill. Amazing, eh? Isn't that amazing? And this was a mystery for a while. What's different about the retinas of Italian men or the visual processing system or something like that? And it was concluded in the end that the difference is that for an Italian man, light blue means something different because it's the colour of the Azzurri, the Italian football team. And there is nothing more manly and aggressive in Italy than playing for the Azzurri. And I've witnessed this. My first career was football. I used to play soccer, football. And I played against Italy. And we were standing in the crowd. And they do their national anthem a bit like we do ours. You know, we know the first line and then that's it. They're the same. And they get aroused to the Azzurri. The song is called The Light Blues. In a bit like we get aroused to Waltzing Matilda. And our Waltzing Matilda is about a homeless man who steals a sheep and kills himself. Theirs is about the Azzurri. These are the words, some of the words, rip their eyes out and stamp them on the ground. So I was there standing up with the team, and when you play soccer, it's obligatory when you're standing up to play with your grobbets. So you're just there just doing this while you're waiting in the national anthems. Because that's what you do. And then I looked over and they were doing that, and the whole stadium was full of black trench coats. And then the Azzurri came on. And I had my head down and I looked up and the entire stadium was light blue. Everyone had taken off their trench coats and they were wearing the Azzurri. It was all men. And they were intimidatingly loud and angry in their faces. And when I found out this result, I thought, well, that makes sense. Light blue to an Italian man means aggression. It doesn't mean relax. And if anyone's wondering about Viagra, Viagra is light blue. For a reason, actually. Isn't that cool? It doesn't have the unwanted cardiovascular effects that a bright red pill would have. Here's the Argentinian football team. I couldn't find the Italians. This is a study that this group did lots of studies where they put a sham head stimulator over people's heads. And they get pain according to where the intensity knob is sitting, even though the stimulator's doing nothing. So that's stimulator setting versus pain, but nothing's happening there at all. No nociception, pain. These are data from our group in people with a condition called complex regional pain syndrome, and we get them to put their hand behind a mirror and look at the reflection of their other hand, and we touch their good hand, and it hurts their bad hand with visual input alone. No somatosensory input during that task. So, this is when you see the red light, this is when you see the blue light. We're differentiating the direction of these without affecting A delta and C fibres. It's not the only example of that. In fact, I won't tell you the next story because I don't have time, so bad luck about that. Pain is a feeling that you have in your body, but it's an output of the brain. That's my view on this. And this is how I demonstrate that in a schematic diagram. So, I put this in last night to be provocative on the basis of our lovely dinner conversation that we had last night. These are, in my understanding, nonsense terms. And I suggest that they're commonly used terms. And I think they're nonsense. I think it's a bit like saying you've got a love receptor. Maybe some of you think you have. This is, in my view, these are more sensible terms for that. They don't carry pain, but they're triggered by high threshold. They're triggered by potentially dangerous events. And these are the terms that we use when we're dealing with patients. So I'd like to give you all a challenge that if you hear anyone in a lecture at this university use one of these terms, I'd like you to give them an aversive stimulus to discourage them from doing it again. I'd like to demonstrate this for you. So Glenn, if you'd be so kind as to pretend you are a student and you ask a question that has one of these terms in it, please. Your time starts now.
Can you tell me a little bit about that pain part?
Ah! So if you could all do that. it would serve my purposes of breaking down, in my view, the thinking errors that underpin these terms. And I hope that provocation is heard in the spirit in which it's delivered. Yeah, sorry. Glenn's just white as a ghost. So how does vision work? Well, my dad said if you're doing a talk, can you put a picture of yourself into it? So this is my dad, and light reflects off the environment, hits our retina, goes to the visual cortex, flips the image, and this is what we see, right? Wrong. It's nowhere near that simple. And I show this visual illusion to patients in pain to get them to understand that what we experience is an effort to get us to behave in a biologically appropriate way. Right, so if you look at this, you guys, hopefully if you look at square A and square B, they look like they're different. Raise your hand if square A looks darker than square B. Thank goodness, Queensland. Fantastic. You're back with the rest of the country again. It's fantastic. But watch this. We'll take that one out to the side, and then we'll take the other one out to the side with it, and they are actually identical. They are identical shades of grey, but you see them as different because there are other cues that you have no idea about that want you to see something that gives you a biologically advantageous experience. Did you see that? Did you see it? Can you tell me quickly what you saw? Did you hear that? Two pandas making love. How did you go? Two blocks on top of each other. Were they the same or different? Well, they look pretty similar. Raise your hand if you thought they were the same. Raise your hand if you thought they were different. This is what you saw there, and they're different, right? But do exactly what this gentleman did. Get your index finger and cover this area here. When you remove that, you'll see they are actually the same. Well done, you. But that information is important for giving you a biologically advantageous experience. So we use that metaphor to teach people about pain. This is what really happens in vision, the groovy stuff. So this is what entertains me as a scientist, what I would describe as the groovy stuff. In pain, this is, if there's any psychology students, this is not right. This is a dangerous situation, and danger detectors send a danger message to the brain, and then the groovy stuff happens, and hopefully this person will experience leg pain, because experiencing leg pain makes him protect his leg. That's the purpose. It makes you do something to protect that part that's in danger. And we summarise that as the brain in an instant decides, is protection required? Do you need full body protection? Have we got enough protection in our motor system, endocrine, sympathetic, immune, to not bother you with it? Or do we need concerted organism behaviour? And if we need that, then let's make it an unpleasant situation so you are driven to get out of it. You are compelled to get out of that situation. So, nociception is activity, in my view, is activity in high threshold fibres and their projections. Pain is the feeling that's in consciousness. And until you have it, it doesn't exist. I think that's a very well justified statement. But the whole system's protecting us all the time. I love this series of experiments done by a close collaborator of mine and one of our joint PhD students. Sorry, not this one, but the next series. This is an interesting study where they looked at withdrawal reflexes. So really fundamental, pull your limb away from a noxious stimulus. You would have all had these things. What they did was give people different odours to smell before they delivered the stimuli. These are odours that are telling the system, okay, there's a certain gas, if you like, in the air. This is what normally happens with the size of the withdrawal response. Get a pleasant odour and there's no effect. Get a neutral odour that's neither unpleasant or pleasant, there might be an effect. But this is the big kahuna. If you smell a disgusting odour and then do a withdrawal response, your withdrawal response is bigger. And that makes a lot of sense to me if the system's about protection. There is credible evidence that there's something dangerous going on here. There's another input, then let's have a bigger response at a spinal level. So this is a modulation that's being generated cortically to change the way the motor system works at a segmental or spinal level. I reckon that's quite remarkable, and it's online and out of your awareness. It's happening right now. You could do this experiment. I'm sure a few of you have generated some disgusting smells in your time, and you could combine that and just see how far your hand moves up when you've just farted compared to when you haven't. Try the experiment. These are the data from Giandomenico Alessandro Magnifico Fantastico Iannetti's lab. He looks at this concept called defensive space using a reflex called the hand blink reflex. It's a fairly fundamental brainstem-mediated response. Stimulate your median nerve and you blink. So 75% of people have this reflex. It's very robust. And it's fairly well understood at a segmental level. What he's shown is that if your hand is closer to your face, remembering that this, until these studies, was thought to be a simple median nerve, brainstem, eye blink. But when your hand is close to your face, the eye blink is bigger. Just have a think about how that could happen if it's a single loop. Something about moving your hand close to your face, your brain is evaluating increased risk of the stimulus occurring near your face. Is that nod if that makes sense? Yeah? Cool. Then they did these experiments. So if you're moving, so this is Sarah, who's one of our PhD students, who's doing this. If your hand is moving towards your face, you get a bigger response. So the brain's predicting, well, it's going to be there any second. If it's moving away from your face, it's a smaller response. Real-time modulation, sophisticated modulation of protective responses. What if you put a barrier between your hand and your face? So now your reflex gets bigger, but if you put a nice solid bit of wood there, the reflex is diminished, goes away again. Because your brain, it's how we interpret it, your brain has realised, well, I'm safe because of this barrier. But if you make that barrier a piece of tissue paper, it doesn't change. So this highly evaluative process is modulating how well you are protected in reflexes. You've got no idea this is happening. I reckon that's groovy, very groovy indeed. So how do we think it works? Well, we don't know how consciousness emerges, and we touched on this subject last night over dinner. How do we feel things? How does consciousness emerge? I don't know. I've got no idea. But we have a model that we try to make sense of it and study it with. So these are brain imaging studies from people who are experiencing pain. For example, here, amputees doing painful movements of their phantom limb. This is from a Polish research group led by Professor Wikipedia. Sorry, that's such a bad dad joke. That's a hot thermode on their leg. So you can see lots of different brain active areas are involved. This is a really sad story. This guy was running at night and ran into the bottom of a veranda and just ripped off a quarter of his head, which was not altogether surprising because he has no eyes, like where his eyes should be. And people were yelling out at the time, "Watch out, mate, watch out the veranda!" He's got no ears, so he couldn't hear them either. No, this is data from people having burns debrided. And it's painful, and you can see it's distributed processing. So we stick that into a model like this where we say, okay, the biological substrate that somehow magically produces pain consists of networks of neurons from lots of different brain areas. It's not a pain centre. And these neurons do lots of different things, but when they work together, they seem to produce pain. However, they are also involved in different neural networks that represent beliefs about credible danger and credible safety. Things you know that you don't know that you know. These sorts of things. Other sensory cues, the middle of that visual image tells you to make the colour of the other things different through the modulation and interaction of brain cells. Social context, and you can put everything in there. As a clinician, we just have to make sure we put ourselves in there, because we are represented in the brain of the people we treat. So we are implanted in there, if you like, and we therefore influence a whole range of other neural networks that can influence pain alongside that. We talked last night about descending modulation, and I would conceptualise this, that the brain is able to correct the danger message coming up the system according to the wisdom of the brain, which is not always true, but it has two systems with which to do that. One is effectively if the brain says, actually the spinal cord's overestimating the danger level here, so it inhibits the spinal cord, descending noxious control. Maybe in other situations, like having a sham stimulator or having your hand that looks like it's about to be touched if you've got a painful disorder, the input from the spinal cord is seen to be underestimating true danger level. So the brain upregulates the spinal cord. In my view, I would conceptualise this like a homeostatic response to correct the incoming, it's a predictive response to correct the incoming signal. And this is really important for us in the chronic pain space because we think changes in the spinal cord, learning in the spinal cord, drives some chronic pain states. If one understands pain to be simply a reflection of tissue condition, so if a patient understands that their pain is just simply about the state of their tissues, we have very strong evidence that I don't have time to go into that says pain begets pain then. The more pain you have, the more pain you will have because it's confirming damage. So we spend a lot of time trying to explain pain to people in pain. And what I mean by that is we try and change their understanding of what pain is from a marker of tissue damage, which it never is, never, even in highly controlled experiments, to a protective conscious experience, trying to promote behaviour. And if any of you are slightly sceptical about that idea that pain is not a marker of the state of the tissues, think about an ankle sprain. Most of you have probably sprained your ankle, torn ligaments, and you might be pain-free 2 weeks later, but you're not back to normal tissue health for another 2 or 3 weeks after that. But your brain sees it not in your interest. Why make you protect your ankle in this situation? But if you go for a run, maybe after a couple of K you'll start to get ankle pain. That's sensible. The brain's saying, hey, you're getting a bit close now, so I'll back you off. It makes total sense to me from a clinical and a neuroscience perspective. So we've got lots of things that happen. I'm going to go through this because you don't need to know that. This is the take-home message of that. This was a sign that I saw in Canada on a highway. I thought it captured central sensitisation really well. We know that the more these neurons send danger messages to the brain, the better they get at sending them. They get very efficient at sending danger messages to the brain. Therefore, the perceived danger starts to get separated from the true danger level. That relationship becomes more and more tenuous, which has major ramifications. And last thing, so I'm about done, but this is really something that we're just excited about at the moment, looking at this idea of how it's all connected. Our protective systems are all connected. And this is evidence that they're connected. So this is an experiment we did a little while ago where we got people who were missing one arm without any phantom pain, but they had an intact phantom, to do this with their phantom. So I'd like you all to do this. Can you just adopt that position with one hand? And we could say that's position 1, and now move it around to position 2 up the other way, as far as you can. That's position 2. This is called the long way from position 2 to position 1. Now I'd like you to move the short way. You can't do it, right? You can't do it? But just imagine that you didn't have the physical constraints. So you had a phantom arm. Can you work out how to do it? And if you can, does your perception of your body change there? And this study, this was 7 experiments in this, but I'm just giving you some data here. This study shows quite clearly that that's exactly what happened. So there are only 7 amputees in this. These are the 4 who said, yes, I've learned how to do it. It took them between, I think, 12 days and 3 weeks to learn how to do it. And the fact that they're all down here, this is a reaction time task you can't cheat on. This confirms their report. This confirms their report. And this is what they described. So this is a drawing that one of them did of what happened the instant he learned how to do this thing with his hand. His structure changed. The felt structure of his phantom changed. I reckon that is amazing. And he said, I've now got an axis through here. And what's even more amazing, he was a guy who would joke around, and whenever you meet him, he'd go and shake hands with you with his phantom. That was his thing. And I was very funny, and I go, oh, hi, and he'd go, hey, Loz, how you doing? And I go, good, thanks, Barrett. Good. You flippin' weirdo. And we came up to him, he just learned how to do it, and I said, hey, Brad, and he went, no, sorry, mate. And he backed away. I said, what's wrong? He said, oh, I just can't do, and he showed me the other hand, I just can't do that movement with my hand anymore because it's hitting the axis. Isn't that flipping remarkable? That his brain structure, the structure of his body held by his brain has morphed, bless you, such that some movements he could do, he can't do now. And these data support his report. Actually, the group data of the 4 lose their ability to do this with their phantom because they've now got an axis going through the middle that allows them to do that thing. Cool, hey? So what we feel our body is like and what it will do for us are clearly very intimately connected. Here's another study that shows connection between a different system. This is Meng. He was in my lab in Oxford. This is his left hand, and this is a prosthetic hand. And if I had more time, I'd tell you the great story about stealing these prosthetic hands. It was Meng's from Singapore. You're not allowed to commit a crime in Singapore. And he did, and it was great to watch. But when you do the rubber hand illusion, you simultaneously stimulate both of these hands, let's say with a brush or something, in the same place at the same time, and quite quickly you feel like you can feel the touch on that hand. And you start to think that's your hand. I mean, you don't really, you know it's a rubber hand, but you locate the stimulus there when you close your eyes, all sorts of things happen. We were very interested for clinical reasons in what happens to the arm behind the board there. And this is what happens. So again, this is 5 experiments. I just pulled out the data that tell the story here. But hopefully you can see this is how much they get a sense of owning that prosthetic hand during the experiment. This is the temperature of his left foot. This is group data, obviously. This is the other hand, but this is the temperature of the hand that's behind the board. This is a limb-specific reduction in blood flow when you have the illusion that your hand's been replaced by an imposter. Now that's a very interesting question to us clinically because chronic pain disorders sometimes, and some of the disorders get this a lot, they feel like they don't own the body part anymore. It's not mine, it doesn't belong to me. So we wanted to produce that experimentally and see if we could replicate the loss of blood flow to the body part, which also occurs in chronic pain, which we can. So this clearly shows that producing the illusion of the rubber hand taking over from your real hand reduces the blood flow going to your real hand behind the board. This has been replicated by other groups now. It's not just blood flow, so this is your reactivity to histamine when you get a prick test on your skin, showing that when you have the illusion, you have a bigger response on the illusion arm than you do on the other arm. But only if you have the illusion, not if we do everything else. So we do the stimuli, we have all these different controls. If you get the illusion, you become more reactive to histamine on that body part. So we've now done a lot of experiments that put together this idea of a cortical body matrix is the word we give to it, or the phrase we give to it, which just suggests to us that really all is one and one is all, that you can't mess with one system without influencing another system. And we're very interested in the system that protects you and regulates you and the space around your body, because it seems to do it both perceptually, so what you feel, and pain is a feeling, and physiologically, what you do with your systems. Which means that we have different ways now to access the pain production system. We should be able to access it by messing with those other systems, if that makes sense. We know that it's disrupted in people with chronic pain, and some of these disruptions are very distressing. And if they don't understand that it's a normal biological effect, they are the things that lead 1 in 5 people with CRPS to attempt suicide or amputation because of their pain. Not just the pain, but the arm that doesn't belong to them anymore, that doesn't do what they ask it to do, that they can't feel touch on, that they end up protecting from the world and getting these motor dystonias where they're completely impaired in a wheelchair from something that started with a wrist fracture, for example, because of the wind-up in the system that becomes so profound. These are horrible situations for these people. We're trying to explain that to them, and the most effective thing we can do in the clinical world so far with people with chronic pain is explain it to them. That might sound really soft, but it's hard to explain that when our intuition says pain is in the tissues and travels to the brain. That's the intuition. And what we're trying to do is say, no, no, no. Pain is a protective device, and any credible evidence that you are in danger and needing protecting will increase your pain. So we say to physiotherapists, don't tell them their disc is slipped and they were lucky that they get out of that. Oh, you've got the back of a 75-year-old, come and see me 3 times a week, you'll be right. Don't say that, because there's danger cues, and danger cues make the pain worse. I hope that makes sense. Now you'll see here, I want you, in fact, can you all close your eyes for 6 seconds? Close your eyes. If you open your eyes, you'll see how many slides I had left that I didn't show you. And I'm even going to resist that. Because whenever you do, for those researchers there amongst you, you will know that it looks like you do a lot of studies. Actually, there are a whole team of people doing these studies around the world, and in our group, this is our research group at our last research retreat in the Clare Valley. Well sustained by good quality red wine. This is our group at the moment. These are our collaborators, and with the work I've spoken about, I'd like to particularly talk about Charlie Spence and Junda Ionetti, Oxford and UCL, respectively. Thank you very much for your patience. I have gone a bit over on my time, but that's all that I'm going to say.
Great.
Thanks, Paul.